My name is Naveed. I am working as a researcher in Department of Water Management of Delft University of Technology of the Netherlands. I have worked for many years for Punjab, and I have measured many field campaigns. I have run many field campaigns in Punjab. And first of all, I would like to explain about the irrigation practices in the Punjab, and then I will explain what is happening regarding the groundwater salinity in the Punjab, and thereafter I will show you some animations and movings regarding the skimming wells, scavengers well, and I have also proposed some sort of balanced scavenging wells that will produce fresh water in the Punjab forever. The aim of today's presentation is what are the skimming wells? Is skimming wells are a sustainable solution, and what is sustainable solution in Pakistani Punjab that we can get fresh groundwater forever. So first of all, I will tell you what are the skimming wells. Skimming wells are the shallow wells penetrate in the upper freshwater zone and skim the fresh water from the salt water beneath it, and often skimming wells have more than one screen, all arranged around a central point to spread out the extraction and thus skim of the fresh water on the top of the salty water. So is sustainable extraction in Pakistani Punjab possible? I will show you with the help of animation, and I will also show you with the help of animation how skimming well works in the Punjab, and either they are sustainable or not we will discuss in the next slides. This is a map of a Punjab. Here you can visualize different doabs. Doab is a local term. It means an area enclosed between two rivers. Here you can see different rivers of the Indus Basin, and area enclosed between them are the doabs. For example, this is Jaj Doab, this is Rachna Doab, and these are the rivers of the Punjab. Punjab was in almost balance before the end of 19th century when the British engineers has started irrigation. There is no doubt that this irrigation has turned the desert conditions of Punjab into the breadbasket of the region. River water was held behind the dams and barrages and is distributed through a network of large to small irrigation canals virtually over the entire region. And because of this irrigation, water table was also raised in the past, because British engineer at that time didn't take into account the long-term impact of the irrigation. They didn't take into account what will be the consequences of the irrigation, but due to the constant irrigation of about 40-50 years, water table was raised and the problems of waterlogging and irrigation salinity induced in the Punjab. That was happened in almost 50s and 60s. Thereafter, the Pakistani government, in collaboration with the foreign consultants, in which United States Geological Surveys have played a very important role, have started a mega projects of scarp tubes in Punjab. What are the scarp tubes? Scarp tubes are salinity control and reclamation projects. These projects were meant to lower the water table, and there were two types of the scarp tubes in the Punjab. One type of the scarp tube was meant to lower the water table in the fresh groundwater areas and to use the groundwater for additional irrigation. And then the second type of scarp tubes were installed within the central areas of the doab, because central area of the doabs were mostly affected by the salinity because of the natural salt, deep and natural salt that was already in housed within those central areas. And that's also relevant to the very old history of the Punjab, when before the end of 19th century. So system was almost in steady state because of the infiltration of the river water, seepage, salt water was infiltration from the river pushed the salt water towards the center of the Doab, and also dried by the evaporation from the central area. And because of this evaporation, salt water was accumulated on the layers because of evaporation, and because of this the situation is like this, pushing from the rivers, and in the central area salt water was at very near to the ground surface, a few meters below. And this is the very steady state situation, and because of the irrigation, fresh water was accumulated on this salt water and freshwater lenses were created, and its depth is variable from 10 to 40-50 meter over the Punjab. Actually, this infiltration And this seepage from the irrigation canals that were built by the British engineers definitely created a new resource that is called groundwater because of the leakage from the irrigation canals. And but due to this, waterlogging and irrigation salinity also induced in the Punjab, and huge hectares of land became unsuitable for agriculture. Therefore, government has started the mega projects of public tubers to lower the water table. No doubt these schemes have provided very good results, and within 30 years, 20, 30 years, they have lowered the water table. And also, but meanwhile, because of the deep scarp tubers that were installed in the central areas, they have also bring the salt water from the deep aquifer into the shallow zone, and situation even became worse from the point of groundwater salinity. Therefore, government has stopped all those public tubewell schemes at the request of the farmers because these tubewells are producing salty and brackish water that was not suitable for agriculture in the Punjab. But at that time, farmers were used to get extra water for irrigation from groundwater. Therefore, they have switched from public tubewells to the private tubewells, their own tubewells that are sometimes called skimming wells. There are large variety of skimming wells are available in the Punjab. As I have already explained about the skimming wells are the shallow wells, penetrate in the upper freshwater aquifer, and they have often more than one screens, up to 26 as has been reported in the Punjab, all arranged around a central point to to spread the extraction and thus skim the freshwater from the upper freshwater layer. So these skimming wells were being promoted by many local and international research institutes at that time in Punjab, in which International Water Management Institute, Colorado State University, and others authors are played a key role to promote these skimming wells in the Punjab. They have many field experiment, many laboratory experiment, and also model studies. But unfortunately, these studies have only limited aerial extent and have of limited duration. That's why they didn't take into account the long-term impact of the salinity, because skimming wells only provide fresh water from the upper surface. They are not removing salt water from the system, and there is no solution without removal salt from the system that I will show you in the next slides. So these are the consequences. I have already explained waterlogging because of irrigation, waterlogging and salinity appeared, and huge hectares of land in the Punjab became uncultivated, unsuitable for agriculture. Thereafter, government installed public tubewells to lower the water table. Then those tubewells were closed at the request of the farmers, and thereafter farmers switched to the skimming wells that were being promoted by many authors. As many few of them are mentioned in this slide, you can see Zuberi and Markwater, John Dew and Larouk, in which Macwater is the main promoter who promoted these skimming wells on the basis of many laboratory field experiment, but all of them of very short duration. Because of this, they didn't take into account the long-term impact of the groundwater salinity. So because of these studies, these research, laboratory experiment, field experiment, and PITs also happened in the past, especially during 80s on skimming wells, and they have promoted and they have concluded that skimming wells are a very sustainable solution. They can provide you the fresh water forever. They have recommended that we could increase the number of strainers, we could increase the distance between the strainers, we can reduce the penetration depth and many other things. By using these criteria, we can get fresh water from the skimming wells. These are the most commonly used parameters of the skimming well that are being used by the farmers in the Punjab. And this is a graph which I have obtained from simulation of many simulation by using different type of skimming wells, in which I have increased the strainers from 1 to 8, and I have also increased the distance between the strainer up to 200 meter, and penetration depth was also reduced almost 50%. And but the concentration from all of the wells over the years show the similar pattern, and because of this reason it can clearly be it can be said that skimming well are not a sustainable solution because those parameters over the longer period, or these design parameters over the longer period, cannot provide a sustainable solution. This is an animation of a single strainer skimming well, and depth of screen is between 5 and 50 meter, and these are the streamlines which are which uh, show the flow, how flow is moving towards the screen. And this is a concentration. You can see concentration below the screen is constantly increasing over time, and salinity front is constantly moving below the screen, and this is year is changing, and this animation is of 100 years. And you can visualize from this animation that skimming well cannot provide fresh water over the longer periods. This is another animation in which I have reduced the penetration depth by 50%. Now screen depth is between 5 and 25 meter, and you can visualize the same process is happening. Saltwater upconing is happening below the screen. What is a saltwater upconing? Saltwater upconing because of the extraction of fresh water over the salty water, then then a cone that was developed like the shape of a mound below the screen is called saltwater upconing. And this process is very common in aquifers, in inland aquifers where salt is present below the fresh groundwater, and also in the coastal areas where intrusion of seawater is important. So now you can see it's a clear cone that can show salt of brackish water is extraction from the well contains concentration of brackish water, and this concentration will increase over time and will not give a sustainable solution. This is an animation in which I have used 4 strainers, and the distance between the strainer is 70 meter, and the depth of the screen is between 5 and 50 meter, and you can see the same upconing, saltwater upconing process is happening below the screens. These lines, these white lines are the stream lines. These show how flow is how flow from the mixing zone, that is a zone due to dispersion is happening above the salt water, and because of this concentration is increasing over time. This is an animation of a skimming well which have 8 strainers, and the distance between the strainers is 200 meter apart, and the depth of the screen is between 5 and 50 meter, and you can visualize the same process of saltwater co-upconing is happening, and streamlines carrying the flow below the fresh groundwater that can be visible at this part. And because of this increase in concentration in the extraction water, skimming wells are not in a position to give fresh groundwater forever. So then how can we get a sustainable solution? No sustainable solution to use groundwater forever in the Punjab if we do not use it conjunctively with canal water. Otherwise, salt water will accumulate due to irrigation recirculation, and groundwater will become unsuitable for irrigation. And I have tried the salt balance of groundwater below an irrigated field, which ensures that the additional irrigation from groundwater remain possible in the future. And this is from this equation we can get that amount of drainage that is really necessary to maintain this system in working. Here you can, D is meant for drainage, I is the irrigation supplies, and C means the seepage from the irrigation canal. That is a huge amount that is happening in the Punjab. And Ci is the salt concentration in the surface irrigation water, and GW is the salt concentration in the groundwater. From this relation we can get the drainage, the amount of drainage that is really necessary to keep this system in working position forever, so that it can give groundwater, additional irrigation from groundwater, so that farmers can get fresh water when their crops need it and when they do not have enough supplies from the groundwater. Sustainable conjunctive use of groundwater for additional irrigation, it requires that we have to remove salt water from the system. If we do not remove salt water from the system, we cannot able to get a sustainable solution. As was happening and still happening with the skimming wells, because farmers are not removing any salt water from the groundwater system. That's why they are not able to get a sustainable solution, because anyway saltwater upconing will happen and it will affect the pump salinity. because the hydraulic gradients in the Punjab are very small, and there is also presence of alluvial ridge in the Punjab, subsurface drainage is not possible, and only we can remove the brackish or salt water from the groundwater system by artificial means, and for those wells is vertical drainage by wells is a suitable way. In the Punjab, additional irrigation from the groundwater is sustainable if the groundwater is discharged at a rate equal to the fraction of the irrigated surface water. And to achieve such a sustainability, a certain amount of brackish water must be discharged. This amount can be determined by assessing the combined salt and water budgets. From the water budgets, we can get the amount of fresh extraction of fresh groundwater and salt water. How can we can get the amounts, and then we can design our system, and then we can get the fresh groundwater from such combined salt and water budgets. And these really played a very important role in designing such suitable schemes. And how can we remove the salt water from the system? This can be performed by squinging, a method in which an extra screen is installed below the regular freshwater screen. And I will show you with the help of animation in the next slide how squinging can work and how squinging can give you a sustainable solution. Here it is maybe important that I can explain you what is the meaning of squinging. Squinging mean for example, if we have a freshwater screen, then it can be used to extract the freshwater, and we can install a screen below the freshwater screen so that we can extract salt water or brackish water from it, and we can dispose it to the drainage system so that it can control the salt water upcoming, and the system could work forever. The analytical numerical models as developed by Alam and Olson in 2013 and 14 that were published in uh, Agriculture Water Management Journal and Hydrological Processes Journal show that the final salinity in the saturated zone reached by streamlines can only be influenced by the inflows and outflows that carry salt. And these are the irrigation water, seepage from the canals, and discharge water. This is the animation of a balanced squeezing well. We can control saltwater upcoming, and we can produce fresh groundwater for the farmers forever by the creation of the balanced squeezing wells. And this animation will show you how balanced squeezing well can work. Here you can see there are two screens. Upper screen is meant to extract and discharge the fresh water, and the lower screen is meant to extract and discharge the brackish or the salt water to the drainage system. In this picture, in this animation, you can visualize the saltwater upcoming process is happening only below the below screen, that is meant for squinging to dispose the system to the drainage. And you can see over the year it is stable. It takes only few years then this cone will stable, and the upper screen constantly able to produce the fresh groundwater. I think I will show you this again. You can visualize what is happening, and you can compare it with the animation which I have shown you before, and you can get a difference, because this process will happen forever, and this process will not able the skimming wells to provide fresh groundwater forever. That's why a squinging screen below the fresh groundwater screen is very important so that system can work forever. This is a graph of the last animation. In this picture you can see blue is meant for the upper freshwater screen, and the red color is meant for the below squinging screen. The concentration in the lower screen reaches to its maximum value in 20 years, then it is gradually reducing because a constant amount of salt water or brackish water is being removed from the groundwater system. That's why its concentration is gradually reducing and will reach to a very minimum value, and it will become stable so that the disposal to the downstream user will not be a problem. Whereas the fresh groundwater screen is stable in almost 25 years, and then it will provide fresh groundwater of 600 milligram per liter forever. However, we can fix this limit according to our requirement. We can change this maybe 500, 200, 300, whatever we want from the fresh groundwater screen, that is from the upper screen. We can preset it, and this has been clearly derived in the papers which I have mentioned before, and this is possible. Sometimes it is assumed that, and it is presumed that by the authors, and many papers have been written, that recirculation well can provide fresh water and also remove the problems of disposal to the downstream users. In what is a recirculation well? Recirculation well is a type of a well in which brackish water or salt water is injected at the deep aquifer so that disposal problem shouldn't be there. This animation will show you the recirculation well. Here you can see three screens. First is the freshwater screen. In this is the screening screen, which is meant for disposal, and this is the third one is the injection screen. This is the injection screen. A part of brackish water from this middle screen is injected back at the deep aquifer in this position, and you can visualize the brackish water is growing under this regime, and it will ultimately affect the upper screen, and therefore this is not a sustainable solution. It is only a temporary or a midterm solution because it can only delay the salinity in the future. It is not in a position to prevent it. This is a graph of the last animation. Blue color is meant for the upper fresh groundwater screen. Red color is meant for the middle screen, that is meant for the extraction and disposal of the salt water to the drainage system. And the upper screen is meant for the re-injection. It is a concentration against the injection screen. Apart from this screen is injected back at this location, that is the lower screen, and you can visualize the concentration against the injection screen is constantly increasing over time, and it will not, and a time will come when it will affect the upper screen, and that's why it is even not a sustainable solution. So the main conclusion of the today talk is, because skimming wells, I would like to summarize. Because of the irrigation practices, irrigation was started somewhere before the end of 19th century in the Punjab, and British engineer has designed many barrages and canals and irrigation system in the Punjab, and the river water was held behind the dams and barrages and distributed through a network of very large and small and branch and distributed canals. And they have also developed the villages in the Punjab. They have also designed the villages and how these villages will be provided irrigation water. Because of the irrigation, because British engineers didn't take into account the effects of the irrigation, that's why problem of waterlogging and salinity because of the irrigation appeared somewhere during 50s and 60s. And because of this, the problem because of this, many public tubers that were called scarp tubers, as I have explained before, were started to lower the water table and to control the salinity from the central areas of the Doab in the Punjab. But these were not sustainable solution, and thereafter government has stopped those schemes, and the farmers switched to the skimming wells. That meant to extract fresh groundwater from the upper fresh zone in the fresh line aquifer. But these were not and still are not a sustainable solution. Still these wells are being used by the farmers, and I have realized from my field visit in the Punjab, and when I was working there, I realized farmers are facing many problems by using the skimming wells, and they are constantly relocating their wells in search of fresh groundwater, but still the problem is there. Therefore, I have researched many years on this topic, and I have concluded that we can create the balanced quenching wells, and these type of well can provide sustainable solution. Therefore, the main conclusion is there is a no sustainable solution if we do not remove any salt from the groundwater system. Skimming wells and recirculation wells are not in a position to prevent the salinity. However, they can delay the salinity in future. The only option is the balanced quenching wells that can solve the problem in the long run. Thank you very much for your attention.